Good evening, beta. Today we will study the chapter number 9 for class 9, force and laws of motion. In this, first of all, we will study that what is force. So, what is force? Any push or pull or hitting an object by any means which changes its state of rest or of motion or of direction, then such changes which occurs in the object due to push or pull or by heating, such phenomenon is called as force. It is a vector quantity. It is a vector quantity. That means it has both magnitude and direction. Its SI unit. Its SI unit is Newton, represented by capital N. Its other unit, we can say its unit may be written as kg meter per second square. Now we will study the effects what a force can do. A force can change the shape of an object, shape and size of an object. For example, the rubber band. For example, the rubber band is when stretched and when it is released. When we stretch a rubber band, it elongates, and when we release it, it again regains its original shape. That means the rubber band is changing the shape by the application of the force, and the size also gets changed. Similarly, a force can stop a moving object. For example, when a cricketer hits the ball, then the fielder catches it and the ball comes to rest. A force can make a body move. For example, when a football player hits the football which was actually at rest position in the ground, then after hitting by the player, it gets started moving. This is another application of the force. Similarly, we can say a force can change the direction of the object which is moving. For example, when a bowler throws a ball to the batsman, then batsman hits the ball and the direction gets changes. Similarly, there are different types of various effects of force we can see in our daily life. So now what we can say about the balanced force, that when two or more forces are applied on an object and the object does not move in any direction, then we say that all the forces, they cancels each other as their magnitude are same. That is, they are applying the same value of force, but their directions are in the opposite direction. Similarly, by mathematically what we can say, suppose this is an object, and in this object if F1 force is applied in this direction and another force F2 is applied in the opposite direction, then suppose both are of 10 Newton, both the forces are of 10 Newton, then we can say F1 is equal to F2, but they are in opposite direction, so we will mark a negative sign in any one of them. And when we say that the sum of these two forces are 0, then we can say that the forces are balanced force. Now, about the unbalanced force, when two or more forces are applied on an object, then if the object gets moved in the direction which the force is greater, towards the direction of the greater force, then we say that the force applied is unbalanced force. Now again, if we observe in this figure, suppose F1 is acting in this direction and F2 is acting in this direction, but their magnitudes are different. One is 10 Newton and another one is 20 Newton. Then we can very simply say that this box will now move towards the direction of the 20 Newton force. So we can say here that force F2 is greater than F1. So now F1 plus F2 will never be equal to 0. There will be a difference, and then such forces are called as unbalanced force. For example, in case of the balanced force, we can say that anything which is kept on the table does not goes down, because the table is again applying the same amount of force to overcome the force which is applied by the books. Such type of forces we can say is balanced force. Now, when anyone hits a cricket ball or football, then we say that an unbalanced force is applied, because the object overcomes the force of friction. Suppose a football player is hitting a ball and the ball starts rolling down. After some time, we have observed that the ball goes slow down, and this slow down velocity decreasing of the football is only due to the frictional force which is applied by the surface of the football and the ground. Because in the frictional force, two surfaces which are in contact are applying opposite force to each other, and such forces are called as frictional forces, which you have studied in your earlier classes. We have also seen the example of friction. Suppose when we are riding a bicycle and we are paddling it. After some time, when we stop paddling, then also the bicycle moves. But the velocity of the bicycle gets reduces. It is again due to the frictional force between the tires of the bicycle and the road. Now, what we can say about it? An object which is moving with uniform velocity, when a force is applied on it, then if it is balanced, that is, there is no external force acting on it. But to accelerate the same object, we have to continue apply a force. Due to this continued application of the force, only the body can be accelerated. Now, what we have studied, that an object will move with a uniform velocity when the force acting on the object are balanced. When the force will be balanced, that means there will be no external force acting on the object. Then the object will move only with a uniform velocity. The velocity may be uniform. But when we want to accelerate an object, then we have to apply an unbalanced force. If we are applying the unbalanced force, only then the body will get accelerated, and till only for that time up to which we are applying the unbalanced force. But when we leave applying the unbalanced force, then again the object will not be in the accelerated motion. It will slow down and the acceleration will get reduced. Now, the first law of motion. In this, the Galileo had experimented a lot to explain what actually happens. Suppose we are taking here an XY plane, and suppose it is frictionless plane, and if a marble is inclined at this angle, if a marble is released on this floor with an inclined plane, and if this plane are also frictionless, then it will try to go up like this. But what we are observing here, that when this marble is coming down, its velocity is more compared to the velocity when the marble is going upwards. Similarly, if I keep this inclination fixed, and if I increases here another, then this marble will again become more slower to go into the second inclined plane. But you can see, if I decrease this inclination, I have decreased the inclination angle. Now this marble will go to a larger distance just to occupy the distance from which it is coming. But if I reduces the inclination to the zero, that is to this, then you will observe that the marble is now moving to a larger distance. The thing here is that the unbalanced force on the marble in this case is the unbalanced force on the marble in this case are zero, because we have taken a frictionless inclination. This activity now suggests us that an unbalanced force is required to change the motion of the marble. Here the motion is being changed. First it was with a higher speed, now the speed becomes changed. So an unbalanced force. Now what is the unbalanced force here? Actually here the force is the force of gravity. Here for the coming down, the gravity is in the positive direction, whereas when it goes upwards, then the gravity is in the negative direction. This gravitational force is now applied on this marble, and so it is an unbalanced force. So we can say an unbalanced force is required to change the motion of the marble, but no net force is required to maintain the uniform motion of the marble. Net force is not there, because if the net force will be there, then the force will become balanced. But we are taking here the unbalanced force. So what we can say here, that an object wants to remain either in the state of rest the state of rest or in motion unless it is compared to do so. So what we can say here, that an object always tries to remain in the same state, either in the state of rest or in the state of motion. The object do not want to change its state, either in the state of rest or in the motion. And this is the first law of motion, we can say. Now, what is actually this? We can also write this in this form also. Look at here. All objects resist, or we can say opposes, the change of state. The change of state, either of motion or of rest. This is actually the inertia. Now we will write the definition of the first law of motion and the definition of inertia. These are the definitions of inertia and first law. Now what in inertia we can see? The tendency of undisturbed. Undisturbed means the tendency to resist or to oppose the position which the object is at rest or in motion. The tendency of undisturbed objects to stay at rest or to keep moving with the same velocity. This tendency is the tendency of the object, that the object do not want to change its motion or of rest position. The same thing is given by the first law also. A body will remain at rest. A body will remain at rest or in motion unless it is acted upon by an unbalanced force. That means this first law is also saying the same thing, that the object will remain at the rest or in the motion unless and until an unbalanced force is acted upon it. If an unbalanced force is acting on it, then only it will change its position of rest or of motion.